Hi guys, welcome back. This is the lesson on solving quadratic equations by taking the square root. And at the top of your notes page and the top of the slide, you're going to see a listing of numbers, and hopefully those look familiar to you. Those are what we know as the perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on and so on. So our first task is to recall, or possibly for some of us learn for the first time, how to simplify a radical without the use of a calculator and without giving a decimal answer. So we're going to be breaking these up into a bit of a pattern. So when you look at a radical and you wonder if it's going to reduce, if it's just a single number like we have in the first few examples, you want to start by breaking it up into the product of two numbers, two radicals, and then you're going to put the square number first and then the leftover part next. Okay. And it's important that you put it in that order. So first thing I should have done, though, for 18 is I should have looked to see if it was in my list. 18 is not in my list of perfect squares. It would have been, right here. So what you're going to do is you're going to look in the list of perfect squares, and from the biggest number down, look for numbers that are factors of 18. And you want to go with the biggest one possible. So 16 won't divide into 18, but 9 will. So we're going to break this up into the square root of 9, and then we think 9 times what is 18, and the answer to that is 2. And the reason we broke it up that way is because the square root of 9, we have a better name for that. That's really a 3. So the simplification for the square root of 18 as an exact radical is 3 square roots of 2. So same idea here, square root of 48. 48 is not in the list. It would have been right here before the 49. So what we're going to do is look down the list, starting with the biggest numbers, and see if any of them divide into 48 evenly. Now, for this part, if you're not real great with multiplication and division facts, then yes, have a calculator handy and start dividing 48 by these numbers if you're not sure. But 36 won't divide into 48, 25 won't divide into 48, but 16 does. So if you take 48 and divide it by 16, this really becomes the product of 16 times 3. So again, I put the square root number first, because that reduces. The square root of 16 is a 4. Now, one thing to notice, I did not write the square root of 4. That's a common mistake, because then kids just keep square rooting. It's just 4 as a coefficient to that radical. All right, number 3. Same idea. 52 is not in my list. It would have been, right here somewhere. So as I move down the list and I start dividing 52 by my perfect squares, 49, no. 36, no. 25, no. 16, no. 9, no. 4. 4 is the perfect square that divides into 52. So it's 4 times 13, and of course I'm a math teacher, so I knew that off the top of my head, but those of you who weren't sure, you would just type that in your calculator. But the square root of 4, better known as a 2, so the simplification of this radical is 2 times the square root of 13. And then they get weird, okay? So now they're going to give us a division question. The first 3 that we did were secretly multiplication questions that we chose to split apart. So if you think about a fraction being a division question, it's the same idea. Take the division and split it apart. So I'm going to just call this for now the square root of 4 over the square root of 9. And then I'm going to think about that. Hey, square root of 4, we have a better name for that. Isn't that a 2? And then square root of 9, we have a better name for that too. That's a 3. So this fraction reduces to just 2 over 3. That was a beautiful question. I wish they all were that nice. They're not. Let's look at number 5. So number 5, same idea. We have a division question that we're going to split apart. So this becomes the square root of 2 over the square root of 3. And then we're like, oh man, neither one of those are perfect squares. And besides a 1, there's actually no perfect squares that divide into them and factor and reduce. So you might think we're done, that this is the right answer. Unfortunately, there's something in math, some really weird rule that says you can't have a radical in the denominator. So what we're going to have to do on this question, and you should write this down for vocabulary, we're going to rationalize the denominator. I'm running out of room, so I'm going to abbreviate denominator. So the way we rationalize a denominator, and you think to yourself, okay, I have to get rid of a square root. Well, what gets rid of a square root is squaring a square root. Well, you can't just run around squaring things in math because you change the value. But you could simulate a squaring. Squaring is when you multiply some number by himself. So what if we multiplied the square root of 3 by another square root of 3? And that seems illegal, right? But in a fraction, if you do something to the denominator of the fraction, as far as multipliers, if you do it also to the numerator, then you haven't affected the balance of the fraction at all, because you're essentially multiplying by a 1. Square root of 3 over square root of 3 is really a 1. So what does that do to our problem? Well, up in the numerator, we would, instead of splitting the multiplication problem apart, we'd smush it back together. That becomes the square root of 6. And then down in the denominator, this becomes the square root of 9. But y'all, we have a better name for the square root of 9, don't we? Isn't that just a 3? So this becomes a 3, and our answer is the square root of 6 over 3. All right, so there was a lot of color going on in that question. Sorry. The next question from kids is, hey, can I reduce square root of 6 over 3 and call it square root of 2? And the answer is no, because there's no 6 in that problem. There's the square root of 6, which is like 2 point something something, something gross, irrational. The 6 and 3 can't reduce in any way. So only radicals can divide with other radicals. Only, coefficients can divide with other coefficients. We got to be careful about that reduction. All right, so that is, in normal math sequence, like you've already seen that and been exposed to that, but I think this year it's possible some of you have never seen that before. So we might just have to practice that a little more. Now we're going to use that skill to actually solve a quadratic equation. So my big note to you guys that you should write at the top of your notes here is to isolate the thing that is squared. That's the goal, because once you can isolate whatever is being squared, then you can apply the square root to both sides of the equation. In number 6, it's already isolated. So we're going to square root both sides of the equation, and we're going to get x equals, now the square root of 16 is wonderful because it's in our list, right? The square root of 16 is really a 4. And if this was your final answer, I'd say you're half right, which is really a bummer because you're missing half of the solutions. Positive 4 is a solution, but so is negative 4. There's a really great explanation as to why this is true. If you think about the shape of a parabola, and then the line of x equals 16 crossing it, it's going to cross at 2 points, at negative 4 and at positive 4. So we just have to remember that when we square root an equation, and really when we take the even root of any equation, any even root, you have both positive and negative answers. Okay, that doesn't have the same rule for odd roots, just for even roots, like square roots and fourth roots. If you're like, oh, that's too much writing, I don't want to write that, then probably what you've seen before in your life is just using the plus or minus sign like this. Okay, I like that. I think the shorthand notation of putting a plus or minus sign works well. So in number 7, we are not ready to square root. You need to isolate the thing that's being squared first. So let's do that. We're going to add 3 to both sides. Little gut instinct, I bet, told you to do that. Just like you would solve an equation, right? A linear equation, but at the end of this, we're going to have to square root. All right, don't square root yet because we still haven't isolated. Now we're going to divide both sides by 2. I'm going to get my head out of the way. There we go. And now we have x squared equals 12. So now we can apply the square root to both sides of the equation. Unfortunately for us, 12 is not in our list, right? It would have been right here, and it's not there. So if I look down the list, can I reduce 12? And the answer is yes, you can. 12 can be written as, the square root of 12, excuse me, can be rewritten as 4 times 3. And then remember, we would reduce the square root of 4 to a 2. And then to put all of our thoughts together, we also would have to remember the plus or minus. So you have 2 answers to pretty much all of these quadratics, few exceptions out there. So positive 2 square roots of 3 and also negative 2 square roots of 3. But again, I like when you do the shorthand notation with a plus or minus. All right, number 8, same idea. We got to isolate first. So I'm going to subtract the 1. And then this time, it's the squared thing, the x squared, is being divided by 5. So we're going to multiply both sides by 5. And then that's how we're going to isolate the x squared. So now it's time to square root both sides of the equation. And as a math teacher, I'm very excited of what I'm seeing here, because I think about, okay, 35. 35 is not in my list. It would have been right there. And actually, none of these, with the exception of 1, and we don't worry about 1, none of these divide into 35 at all. So I don't have to reduce 35. The only thing I do have to remember is that my solution is both positive square root of 35 and negative square root of 35. That plus or minus is usually where I get kids. They forget it. It's easy to forget, but like in the instructions, I usually put like, don't forget you have two solutions. So hopefully that reminds you. All right, number 9. You are still needing to isolate the thing that's being squared. Now, one thing that's different about number 9 here is the thing that's being squared is this expression x plus 5. So that's what you're supposed to isolate. You cannot distribute that 1/3 into the parenthesis because x plus 5 is being squared. So it's really x squared plus 10x plus 25. So unless you took the time to FOIL it out, you can't distribute the 1/3. So scratch that idea. Instead of distributing the 1/3, we should get rid of it. So instead of dividing by 1/3, I like when you guys multiply by the reciprocal instead, because of course we're going to do that to both sides. The reason we don't like you to divide by fractions is because if you use your calculator, most kids type it wrong because they don't use parentheses. Okay, it's time to square root. So if I square root both sides right now in the problem, the left side's wonderful. The square and the square root will just cancel each other out, and you have an x plus 5. And then because I tend to forget this, I'm going to put down a plus or minus right now. And then I think about 21. Well, 21, not in the list, and none of these divide into 21. They're not factors of 21. So we're just going to leave this as the square root of 21. So only one more step left because you still want to solve for x. You just got to subtract 5 over. Now this is where it's going to kind of mess with you a little bit. These are not like numbers. We have a radical, square root of 21, and then we have a negative 5, which is an integer. And you can't add or subtract them together. So you're like, well, great, what do I do? So you write down x equals, I tend to put the negative 5 first. And then instead of saying plus square root of 21, and then also negative 5 minus square root of 21, you guessed it, there's a shorter way to write that. Most humans, including this teacher, would just write, let me move my screen down a little, x equals negative 5 plus or minus the square root of 21. Now, if you were to separate your two solutions, that's amazing and just really, really thorough. That shows me that you understand that there's two solutions there. But if you're lazy like me, you're not going to bother. All right, number 10, same idea. We want to isolate the thing that's being squared. So once again, this is the thing that's being squared. So let's divide by 5 on both sides. So now we have the quantity x minus 1 squared equals 5. And then now it's time to square root. So we end up with x minus 1 equals, because I just took the square root, I'm going to put a plus or minus on my solution so I don't forget it. And then I think about 5. Well, 5 is not a perfect square, and it doesn't have a perfect square as a factor because it's prime. So I'm just going to leave that as the square root of 5. And then one more step and we're home free. We're going to add 1 to both sides. Now it's your choice. You can separate them or you can just write them as a single line. I'm going to be lazy and write them as a single line. 1 plus n minus the square root of 5. Now, because I do want to be thorough for our friends who are just looking at our notes, I am going to write down the two solutions off to the side here. Y'all don't have to. I just want you to really understand that there are two solutions. There's two irrational solutions. They're disgusting. This will come up. I'm going to put or here so I don't confuse my readers. This is going to come up in an upcoming lesson, actually the next 2 lessons for Algebra 2, about how we have two solutions and what they really, really look like. So I don't think it would kill you guys to practice writing them separately, but I understand if you're in a time crunch, you don't want to bother doing that. And let's look at an application. Why not? It's a fun one. So if you have an object that is being just dropped, which we saw this in modeling, right? You have negative 16t squared plus initial height. That's how you calculate the position of the object at any given time. And this is measured in feet and seconds. So there's no velocity, right? Because we're just dropping this object. And we're going to see a pretty cool problem coming up here. We have a stuntman who's going to fall out of a window. So he's not launching himself. He's just literally dropping out of the window and is 100 feet above the ground. So that clue right there is his initial height. Remember that little 0 subscript means initial? And he's going to fall down to a cushion, thank goodness. It's 26 feet wide, 30 feet long, but this is the important clue. It's 9 feet high. So this position, like this would be his final position, which I think they used a capital H. I want to use the same thing here. Remember, variables, they can use whatever they want. We have to know what they stand for. So they want to know how many seconds until he like just touches the cushion. Obviously he's gonna, bounce into the cushion a little bit. They just want to know exactly when he's gonna hit it. So we're gonna set up that equation. Remember, the equation that they just gave us was h equals negative 16 t squared plus the initial height. So plugging in those clues that we were given, the final height is not the ground this time because that would hurt. His final height is going to be 9, the height of the cushion. And then negative 16 is the gravity constant for acceleration due to gravity. And then his initial height was 100. So this is a good candidate for solving by square rooting. There's t squared in the problem, and that's the only variable. So I should have wrote a little smaller, I suppose. We're going to subtract 100 from both sides here. Oh, I don't have a calculator handy. Well, this part I can do in my head, right? We got a negative 91 equals negative 16 t squared. So my next two steps are going to happen on the calculator. This is an application question. I don't want a radical answer for an application question. I can't run up to my producer and be like, hey, your stuntman's going to be falling for square root of 13. Like that's stupid. So we're going to do decimal answers. The next thing I'm going to do on my calculator is I'm going to divide by 16. It's going to be gross. And then my final step would be to square root. And we'll talk more about that in a moment. Let me go grab my calculator. I already should have had this going up. I forgot we had the stuntman problem. How y'all doing? It's good? Okay. I'm at school, if you can't tell. I'm in the math office. Actually, our kitchen where we eat lunch. Pretty cool decoration behind me, right? All right, so negative 91 divided by negative 16. I could have dropped the negatives, I suppose. I already know it's going to be positive. And then I'm going to square root that number. So square root, and then neat little trick. You can just do second negative sign, and it pulls up your previous answer. So I know from my work in this lesson, my answer is technically positive and negative 2.38 seconds. But I wouldn't assume that the negative has anything to do with this question because that would be like before he jumped. So that doesn't have anything to do with this question. So in application questions, you don't typically use the positive and negative answers, just the positive answer. So 2.38. Remember. All right, so t equals 2.38, and this was a label of seconds for time. So that's going to be important to my producer because they're going to want to know how much footage they have to work with and how much time they want to spend. Are they going to do one of those weird camera tricks where they he's falling and he's falling and he's falling. So here they want to know 254 frames per second is the speed at which they're recording this fall. So how many frames are they going to be able to take up with this just fall without doing any camera tricks? So if we got 2.38 seconds multiplied by 254 frames per second. All right, my friends who have done some of this work in chemistry or a science class, you'll notice that the seconds are canceling out in this problem. And we're going to end up with a label of frames, which makes sense. This just kind of helps me make sure I have set up my math appropriately. So I'm going to multiply this answer right here by 254. And I'm going to go tell my producer you have about almost 606 frames. I forgot what the answer was. 605. Yeah, I'll just write down 606. I don't know enough about movie production to know if you can have a partial frame. So I'm going to say about 606 frames. I should go ask Mr. Stangy. He would tell me, right? All right, I think there's a couple more follow-up questions here. Same idea. We have an object falling. It's same thing measured. This is an American problem measuring in feet per second. We talked about that in another lesson. So we have, what if it's 100 feet in the air versus 200 feet in the air? And then if we were in class, I'd be asking you guys this question. Do you feel like it's going to take twice the time? I don't know. Now this time, they want it to hit the ground, I believe. Yes, so the ground. So that means your final height or position they're using, your position this time. They switched variables on me. Oh, no, they didn't. No, they didn't. Here's your formula right here. So your final height, they're using a lowercase h this time, is going to be 0. So if I set up my problem, I'm going to say 0 equals negative 16 t squared plus 100. And then over here, it's going to say 0 equals negative 16 t squared plus 200. So think to yourself, is it going to be twice the time? Do you have your answer? So I'm about to tell you the answer. No, it's not going to be twice the time. Let's find out why. All right, mathematically, we're going to subtract 100 here. And over here, we're going to subtract 200. So I'm sure you can guess what your next step is going to be. We're going to remove that negative 16 coefficient by dividing. Face, get out of the way. Ooh. Took me literally there. All right, so I'm going to divide by negative 16, and I'm going to divide by negative 16. I'm going to divide by negative 16. I'm going to divide by negative 16. Right now, it's going to appear like, yes, the answer is twice. But our next step on our calculator is going to be to square root all of this, right? Over here too, I suppose. Wow, this is a hot mess. Now, the reason I'm drawing all of this on my paper is because I'm about to go to my calculator. I'm going to forget all this problem in a minute. We got 100 and 200. It shouldn't be that hard, right? So this time, I'm going to leave the negatives off because I know they're going to cancel out. So 100 divided by 16 is that decimal. And if I were to square root, which I could have done this all in one step, that's the answer to the first question from 100 feet. Now this time, I'm going to type it all in at once. If you had the square root of 200 divided by 16, look what happens. That is definitely not twice the time. So the mathematical reasoning is because your last step in that algebra sentence was to square root. So even though you have a multiplier of 2 comparatively for your answers, once you square root a 2, that is no longer a 2. I don't really know what it is off the top of my head. It's a 1 point something. Good. So either way, it's not going to double the answer anymore. It's going to be less than doubling the answer. So, okay, 2.5 versus 3.54. 2.50. 3.54. And we've taken some rounding liberties here, but the point is, no, they are not double. The mathematical reasoning is because when you square root the factor of 2, that is no longer a 2. I do have a calculator here. I could confirm that square root of 2 is something else. It is, 1.41. It's pretty good. All right, so it's about 1.41. I'm going to write down that. That note's not going to make sense to anybody but us. All right, so that is your lesson on how to square root to solve a quadratic equation. This is a really important building lesson because it's going to build up and help us in our next 2 lessons, or a couple lessons from now. And we're going to use this skill quite a bit in life, math life, that is. All right, good luck, everybody.